Principal of this college, Professor Mahavir, my teacher, Professor N. Srinivasan, and my friend Karthik, who studied in the next section, and my dear juniors, ladies and gentlemen. All right, it's a privilege to give a talk on the same place where I studied 28 years back. Yeah, I have given talk in so many places, but here I'm feeling slightly nervous. I don't know why. Anyway, I'll make up. So the title of my today's lecture is Applications of Mathematics in Machine Learning Problems. So as Madam said, I am from Indian Institute of Technology, Roorkee, and the building that you are seeing here is 175-year-old building. So we are celebrating our 175 years of IIT Roorkee at Uttarakhand. Okay, so quickly I'll move on to the topic. So, organization of the lecture today is the human action recognition, where how the mathematical problems, right? So, where we will focus on the mathematical problems, because I heard that you are the mixture of mathematics and computer science students over here. So, we'll see, right? So, how mathematics is going to helpful in future extraction, how mathematics is going to helpful for the classification algorithm like LDA or SVM or neural networks, right? So that we will study, and then finally I'll end up with deep learning applications. So nowadays, right, CCTV camera is very common or popular, right? So we'll see what action is going on. Suppose I want to analyze a video, right? Something has happened. For example, there is a theft in ATM machine, right? Or there is some problem in the railway station. So how to determine the action, right? So how the machine learning algorithm, particularly the artificial intelligence algorithms, are useful to detect these. For example, here you are seeing three different videos, right? One is RGB, right? Red, green, blue video. That is what the usual video that we see. The second one is a depth map, right? Where you cannot find the image of the persons, but what exactly he or she is doing, that we can see that. And the third one is if anything happens in the night, right? So particularly in the border area, right, intruder may enter, right? For example, Nepal border or Chinese border, people may enter, right? So in that case, they fix a camera which is useful for detecting the night vision, right? So in all these problems, we are going to focus how the machine learning algorithm we are going to apply, right? And in machine learning algorithm, what are all the mathematical part we can use it, right? So for example, here in RGB video, you can see there is a simulation. A person is throwing the ball, another person is eating the ball, and the third one is, right, collecting the ball. Suppose I want to analyze, let us say a T20 match video is given, right? It's almost 3 hours, 3.5 hours video. Right, the problem is to determine the frames where the batsman is hitting sixes. Right, suppose I'm giving this problem to you. So what you will do, assume that you don't know machine learning. So you have to watch the 3.5 hours video and then pick the frame. Okay, these are all the frames where the batsman is hitting sixes. Correct? So now, instead of the human, can machine do this? Right, so for this we have to train the machine. Right, so we have to train, what do you mean by sixer? To the machine, we know, right? We have to train the machine. That means you have to train with many videos, many images, right? So this is called the process of training in neural, in machine learning or in artificial intelligence. So we are training the machine, right? So then, right? So for this we have to make a algorithm or model, and then we have to use several, huge database, right? So train, what do you mean by sixer? Right? Imagine we are training for the machine. And then the real video will be given. Right? The real video will be given, and the machine will determine, okay, these are the frames. Right? So 10th frame, 100th frame, or whatever the numbers. Right? So it will give you the output. So you don't need to waste your time for 4 hours, right? The machine will give you in 10 minutes. So this is the problem of video analytics, right? So in the database, so we are going to uh, right have the algorithm. So this is called the classification. It will classify, right? These are all the frames the batsman is hitting sixer. These are all the frames the batsman is hitting fours. These are all the frames the wicket is falling. All right. So then that is called the class label. The fours, sixers, and wickets, they are called classes. Right. So this is how the video analytics problem works. So imagine now the situation, right, where you can find the CCTV camera, right? What action is being done by the human, right? So we also call it as a activity recognition problem. So activity recognition, you can see that, right? So here a person is doing, right, a thumbs up, right? So which is a simple gesture, right? Second one is the action. A person is like eating the ball or even walking, running. So these are all called the actions. And the third one is the interaction. All right. So human interaction, or even if you are right playing with the mobile, that is also interaction. That is called the human machine interaction or human object interaction. And then right violence in the stadium. Recently also it happened, right, between Pakistan versus Afghanistan match. The violence happened in the stadium, right, or stealing in the ATM machine, right. This is the worst problem nowadays we are facing, right. So in these situations, will we get automatically some message, right? So that is what the idea. So levels of human activities go like this. So now I'll start with the problem of human action recognition, where how we are going to use the traditional machine learning algorithm, right? So then I will give some of the applications where deep learning algorithms nowadays, right? The researchers are working with the deep learning algorithms. So we will talk about the deep learning algorithms. So here you go. So you can see the left side few images, 12 images. Assume that a CCTV camera is there in the parking lot, right? So now assume that we have 12 different cameras. So each camera will give a data, right? Different data. For example, you want to analyze, let us say 24 hours video, which is a huge, because you have 12 cameras, all the cameras are producing a data. So from this data, let us assume that we are finding out the common area, all right? So the second image is showing, I'm not sure whether the marker is working. So in the second image, you can see that the common area. So the common area is obtained based on image mosaicing, right? Image mosaicing in the sense, we all know that Google Map is not a single image, right? Google Map is a set of images, they mosaic. Mosaic means stitching, right? In the layman context, it is called stitching. So image processing context, we call it as a image mosaicing. So now from these 12 images or 12 data, we have to get the common data, right? Assume that the video is running for several hours, right? It's a CCTV footage. So now from this, right, I want to determine what are all the human action is being held in this parking lot, right? Some people may walk, some people may run, some people may fight, right? Can your machine detect this? So that is what the challenge in the problem, automatically. So if there is some fight, right, or in the ATM machine, some unpleasant activity, or during night vision, some intruder is entering. So can the signal goes automatically? Nowadays, IoT is another popular area, right? Assume that your mobile is connected, right, with the network on this, right? So automatically signal goes. For example, in the bank, something happens, right? Automatically signal goes to the main person. So in that case, you can alert the system. So that is what the idea of this was. Okay. So come to the technical point of view. Assume that you are seeing some of the persons are walking, right? So first I have to determine the region of interest, right? So here people are walking. We know that. How machine knows, right? That is a challenge. So here you go. Here you have right? Some persons are walking in the three images. And then I have to determine, this is called the region of interest. The last one, we got the binary image, the black and white image, right? So this can be determined by finding out the background subtraction. For example, jth frame, the person may walk, right, at some distance, right? For example, the person is going here, right? At jth frame, they may walk at some distance. J plus 1th frame, they will move some other distance. It is obvious. They are called dynamic objects, right? Dynamic in nature. Whereas if you look at the car will be stationary. Jth frame and J plus 1st frame, they are going to be same, right? They are called stationary object. So now, once you determine this, so there are several algorithms to determine the region of interest. That means how to determine the movable objects, right? Motion. So once you determine this, right? So what are the basic steps you have to do for machine learning algorithm? So for example, I may not use the entire image, right? It may contain 1000 pixels. The data is slightly huge because I am dealing a video, right? So what I will do, I will select certain features from this image. So for this, let us say that is called skeleton. For the image that you are seeing in the left, I am finding out the corresponding skeleton. Right? Skeleton, exactly what we have in the human. Now we call it as a bone, right? So exactly it follows. The main idea, we are selecting the feature here, right? We call it as a feature selection. The reason here is you may have 1000 pixels there in the original image. So here you will have tens of pixels. That means you are reducing a data. So imagine one frame we are reducing a data. So you may have a huge frames. For example, 30 minutes video, if I am handling, right? 30 minutes video, if I'm handling, I will have a huge data. So each frame I have to find the features. I have to select the features like this. So that is called feature selection. Once you select the features, for example, that is a walking image. Assume that it's a walking image or a running image. So I have to determine the features, right? Walking feature, fighting feature, running feature, right? All may be different, right? I have to determine the feature vectors. This FV1, FV2, right? That one you are seeing, FVI plus 1, they are called feature vectors, right? So then I have to apply the classification problem, right? First, initially I have to train. I have to train and I have to get different kinds of skeletons. So then I will go for the classification algorithm, right? In today's talk, I'm going to talk about LDA because it contains some mathematics and statistics, right? Support vector machine, you might have heard, neural network, right? Linear discriminant analysis. So these are all the feature selection. These are all the classification algorithms, right? And then we are determining the action. So here, the machine learning algorithms, right? Many are talking, right? Artificial intelligence, deep learning. So the machine learning algorithm, it is divided into 3 categories. One is supervised learning. Second one is unsupervised learning. And the third is reinforcement learning. What do you mean by supervised learning? Assume that a robo is there, right? And trucks of fruits are there. So now you are assigning a job to a robo to classify the fruits. The fruits may have apple, mango, banana, grapes, etc. Right? So you are giving a job to the robo. The robo has to classify. So you are providing the training. That means you have a class label. Class label in the sense you are training to the robo, that is, this is apple, this is banana, this is grapes, etc. Right? That means you are giving a class label. Right? You have to train initially, right? When the child is born, 6 months old or 1 year old, right? Many of you might have experienced as well. Mother is training the baby. He is your father, he is your brother, right? She is your sister. So then after 1 year, 2 years, 3 years, the child will himself or herself learn. Right? So this is called the supervised learning. You are giving a training, you are giving a class label. That means you are training the robo with this is the fruit. Let us assume that 70%, 80% of the fruits we are giving a training. And remaining 20% you are testing. Yes, we will do that. We will ask, who is he? The child has to say, he is my brother. Right? Then you will be happy. Right? The child has to say, she is my sister. Right? Or you give some task. Right? Some 10 objects you put, okay, bring the ball. The child will go and fetch the ball. Right? So that means you have given a training. Okay, this is the ball. Right? This is the bat. This is some object. This is a toy. So all you are giving a training and then you are testing. How you are testing? So go and fetch the ball. So if the child fetches the ball correctly, right? Obviously the parents will be happy. That means that is called 100% accuracy. So similarly, we will do it in the machine. Right? So we will ask the robo now to classify. Can you pick a banana? Right? Can you pick a orange? Right? Most of the Japan restaurants, the humanoid are working. You might have heard the news in the WhatsApp or Facebook or even the news. Most of the humanoid. So you are ordering, right? I want, let us say, idli dosa or right, French fries. Humanoid are bringing. Instead of servers, humanoid will bring. Right? So they understand what exactly we told. That means they have been trained. Whatever the menu are there, they are being trained. So these problems are called supervised learning. What do you mean by unsupervised? Now I am not giving any training to my robo. Without any training, can the robo classify the fruits? So how they will classify? Based on, let us say, shape. Shape of the banana is completely different from shape of the orange. Alright? So it will fit some features. Based on the features, it tries to automatically classify. The classification is called unsupervised learning. Right? And third one is a reinforcement learning. What do you mean by reinforcement learning? Assume that a monkey is there. Right? You are assigning some job to a monkey. If it does correctly, you are giving banana as a gift. If it does wrongly, you are giving a beet. Right? So in the process of reward, that means a gift and beet, the monkey starts working properly. So this you call it as reinforcement learning. So you have to apply the reward function and the beat function. Right? So based on this, machine will start working properly. You call it as a reinforcement learning. So any machine learning algorithm, people are talking about AI, so will fall under one of the categories. The first one is relatively simple. So the second one, many people are trying. Our human brain almost work like an unsupervised learning. Right? So yeah, we need a semi-supervised. That means initially we need some training. After that, right? So automatically we will learn. Right? So here in this case, we will focus on supervised learning algorithm. So here you go, you are given, right, the video like this. So this is a video frame. The first one you are seeing a video frame. From the video frame, we are extracting the region of interest, the black and white image. And then we are finding out the feature selection. From the feature selection, we are obtaining the feature extraction. Features means, for example, orange. So you know the feature, the color, or a structure, shape, texture, right? So these are all called the features. So walking, this FE1, the vectors, the feature vectors are nothing but what features you are extracting from the fruits, right? And here what features you are extracting from the actions, right? And then apply some classification algorithm like LDA, SVM, or you might have heard neural network, right? And then determine the results, final results, right? So for this, I talked about the skeletonization, right? So for this, we have used our own work. So what we have done for the 3D objects. So here we are going to apply for the 2D images, right? So for example, here, Any image can be represented as a function, f of xy, right? The two-dimensional function. Right? So now I determine, partially I differentiate with respect to x and with respect to y, right? The function f of xy. Partially I differentiate with respect to x and respect to y. I will get I vector of dou f by dou x plus j vector of dou f by dou y. I don't have a board, otherwise I would have written here. Okay, here you are. Okay. Can I have a mark? Anyway, fine, I'll continue. So, you have a vector, right? Now you are from the function of two dimension, right? F of xy, you determine, you are finding out dou f by dou x, right, along x axis, and dou f by dou y along y axis. So you will get the vector like this, right? So this is a vector space. All right, now you can see over here, all right? So here, right? So these are the vectors. So now you are seeing here, some of the vectors from different directions are converging, right? Some of the vectors from different directions are converging, right? So we call these are the converged areas, right? For example, here, these are the converged areas, right? The vectors are intersecting from different directions, at least two vectors, right? Some of the places, 5 vectors are intersecting. For example, here, in this area, 5 vectors are intersecting. One is from this direction, second, third, more than 2, right? So at least 2 vectors that they are intersecting, we are finding out the point, right? We are finding out the locus. So for example, here, so this is the shape, right? So this is the shape where at least 2 vectors are intersecting, right? So this is nothing but a skeleton of that image, right? So for example, the image may have m cross n data, right? I am reducing it to only if I consider, let us say, this curve, the skeleton. So I am reducing the data. That is called the feature selection. So I'm not going to keep the complete data, because my computational power I require will be more, right? So I'm reducing the data. I'm reducing the data. So the reduced data means, okay, handling these data, because further you have to, right? Further you have to develop some algorithm. So instead of using the original big data, I have now reduced the data. So that is called the feature selection. Right? So assume that I have determined the skeleton, right? Coming back to the problem, assume that I have determined the skeleton. So now I use the bounding box. Bounding box is the ellipse, because it is compact. If you use the square or a rectangle, unnecessary black pixels will be there. So now I have a compact ellipse, and then I am dividing this into n sectors. Ellipse can be divided into n sectors, right? And in each sector, we are finding out the number of pixels, right? So for example, I have the second sector. The second sector, what are the number of pixels? And then I am dividing with the total number of pixels. So which you call it as feature extraction. For example, here F2J, right? In this representation, F2J stands for, in the jth frame, right? You have, let us say, R consecutive frames. In the jth frame, you are finding out the number of pixels, and then it will be divided by the total number of pixels. The denominator denotes the total number of pixels in the skeleton, right? And you have, this is called the jth feature vector. For example, assume that I have a running sequence, I have a walking sequence. So I am determining, suppose I have R consecutive frames. So these are my feature vectors, right? For example, the robo has to pick banana, right? Shape of the banana is different from mango, right? So we know the shape, that is one of the features. We know the color, that is another feature. So here F1, F2, F3, FR, they are nothing but the features of some action. Assume that it may be running sequence. For the running sequence, that this is the action, right? This is the features, right? So like this, you have to determine the feature. So this is based on completely a geometry. The geometry based feature extraction, one of the popular areas 10 or 15 years back, right? Only the based on the geometry, mathematical geometry. So the geometrical features, you call it as geometrical features. So determine the geometrical features, all right? So any shape you are given, for example, this room, you say parallelepiped, parallelepiped. Or any ball I have given, you say sphere. Mathematically you relate, right? So you write mathematical equation. So like this, geometrically I try to determine what exactly the action is, right? What exactly the object is, right? So like this, you are getting the features. So that means you are training your machine, right? So you are saying these are the actions. For example, in a cricket match, you are telling the machine, so this is meant for sixer. This is meant by sixer. This is meant by fours, right? This is meant by wickets. So you are giving, with the so many database, you are giving a training. So from this training, right? So we have to classify them. Assume the training is over. So now the real video will be given to you. That is the input of the problem. So from this video, your machine has to determine, right? These are the actions. These are the sixers frame. These are the fours frame. Or in the police department, they look for some criminals, right? Many movies you see. So they give the sketch. Or, right, what do you call? The resembled face. It's not the exact face. Then from the database, yeah, many movies, recently also some movie came. So it automatically determines the exact face, right? So you have an algorithm. So that is a machine learning algorithm. So from the database, you have trained. Train means you have drawn the sketch. Usually they do that. You might be knowing this, right? So from the sketch, that is a training. You're giving a training to the machine. Then it will determine the correct person. So that is called the classification, right? So in order to do the classification, so I keep on saying there are several algorithms. And today's lecture, I'll focus on the problem called linear discriminant binary class problem, right? So what do you mean by linear discriminant binary class problem? LDA. We call it as LDA. So assume that there are two classes, right? One is a red in circle and blue in square. Right now the algorithm, so we know that if I am asking you to classify these two, you put a line. One line between this red and blue, and you say this is one class and square is a second class, right? But how machine knows, right? For example, I am going back to the traditional machine learning approach, right? Which we call it as the LDA. So let us say class 1, we consider x1, capital X1, and the second one is x2, right? So it's a two-dimensional points. So now we determine mu, that's mean mean, find out the mean, right? Find out the mean of both the class. One you call it as mu1, second one you call it as mu2, right? Determine. So you will get mu, which is not very difficult. Find out the mean. So once you determine the mean, find out the covariance matrix. Now I'm slowly introducing the mathematics, right? For one class, find out the covariance matrix. So covariance matrix, we know that summation of x minus mu into x minus mu, the whole transpose. All right. So find out the matrix. The matrix is S1. Right. Similarly, find out for the second class. Right. For the second class, this is your covariance matrix, S2. So once you determine the covariance matrix, next, the concept is we are going to find out within class scatter matrix. Within class scatter matrix is simple. Add both the covariance matrix, S1 plus S2. Right? You call it as SW. So you have another matrix, right? Which we call it as a within class scatter matrix. And then you have to determine the between class scatter matrix, SB. Alright, you already computed mean mu1 minus mu2 into mu1 minus mu2 transpose, which will give you 2 by 2 matrix, right, which we call it as a between class scatter matrix, right. So SW, SB, mean, everything we calculated. So these are the simple matrices we computed. So now once you compute, you might have heard in linear algebra, eigenvalue and eigenvector problems, right? So now find out the eigenvalue and eigenvectors for SW inverse into SB matrix. I will tell you why, right? We will come to the theory part on LDA. So compute, it is not very difficult, right? You might have studied AX is equal to lambda X, lambda you call eigenvalue, right? And X is the eigenvector, right? So determine, so it is giving two eigenvalues. One is 0, lambda 1 is 0. Another lambda 2 is 12.2007, right? So one is a non-zero, another one is a 0. So now I determine eigenvectors as well. So you find eigenvalue and the corresponding eigenvector. For 0, eigenvalue 0, what is the eigenvector? For eigenvalue 12 point something, what is the eigenvector? Find out the eigenvalue and eigenvector, right? So now what I will do, I will use the largest eigenvalue. I will tell you why we are going to use the largest eigenvalue. Find out the largest eigenvalue and I am determining the corresponding eigenvector. For example, either you can directly compute like this, right? We have computed SW matrix, SW inverse into mu1 minus mu2, find out this, right? And or otherwise the usual way, right? Usual way of finding the eigenvectors. For example, for 0, right, your eigenvalue, one of the eigenvector is W1, right? So minus 0.05755 and 0.8178, one of the eigenvectors. And for eigenvalue 12, eigenvector is W2, right? So now I consider the largest eigenvalue, 12.2, and the corresponding eigenvector, or directly it will give, you look at the value W2, the vector W2, eigenvector, 0.9088 and 0.4173. So you can get the same, right? Directly when you apply SW inverse into mu1 minus mu2, you are getting the same. Either you get this method or find out your traditional eigenvalue, eigenvector solving problem, right? Now I will tell you why I am choosing the largest eigenvalue, right? For example, if you choose the smallest eigenvalue, lambda is 0, right? So in that case, this is your eigenvector, the blue in line. The blue line is your eigenvector. And this is my class. The red class and blue class are there. If I rotate this line to x-axis and I am trying to project these points, you can see that still I can find the scatter, and then I am taking the Gaussian, right, the Gaussian curve. For these data points, I am taking the Gaussian curve, red and blue. This is for the smallest eigenvalues corresponding eigenvector. The blue in line is the eigenvector, which corresponding to the smallest eigenvalue. But here I am seeing the class is not being separated. But when I take the largest eigenvalue, you can see the beauty, right? This is the largest eigen, the green in color, green line. The largest eigenvalues corresponding eigenvector, the points are projected onto that green line. Assume that I rotated to x-axis. And then you can see, take the Gaussian, the classes are being well separated, right? This is how, right, the robo is finding. Assume that this is banana, this is grapes. So here it is. This is red color, this is, right, blue color, right? The red class and blue class, right? Simple your eigenvalue, eigenvector problem. So you are using your basic statistics, finding out the mean, covariance matrix, right? All these you might have studied. So this is the application. So now it determines the two classes, right? So we can solve for n classes as well, right? So this problem is called the dimensionality reduction.